All right, hello everyone. Today we're going to cover really as your companies make transitions to the cloud, whether that be full public cloud, hybrid cloud, bursting to the cloud, or even just adoption of SaaS services. How do you maintain visibility into the experience of your end users? How do you make sure that as these business critical applications leave your control and go to run on someone else's infrastructure, running in public cloud, in platform as a service, in infrastructure as a service, or software as a service, how do you make sure your users are having a good experience and they're being productive in their job? To do this, we're going to talk a little bit about AppNeta, how we actually make this approach possible, but really a number of things you need to keep in mind as you make this transition. A lot of the tools you have in place today for traditional IT management were designed for environments where you controlled everything. And that's simply not the case. Your users and the applications. And the internet is not really designed to give you the type of information you can typically expect for devices you control, for servers you control, for routers and switches. You're used to getting a set of information from all these solutions to make sure that they're working and they're working well. That's simply not available in cloud-based solutions. So how do you really make sure that when you make this leap, you maintain as much visibility as possible and you ensure that people are happy with the experience, because this is a critical change for companies and it can be quite stressful in a number of locations. To do this, this is really the foundation on which AppNeta is built. We've been in business since 2011. We're really focused on measuring the user experience of any web application, whether it's something that you built yourself, a service you run internally, a service you sell as the core of your business, or a web application that you consume, such as a SaaS service. If it's a web application and it's meaningful to your business, we can make sure that it's working and working well. We do this obviously as a SaaS solution. We've got about 650 customers running in about 100 different countries, and we're designed from the ground up to scale to large organization sizes. So today we're collecting at about 100 billion daily metrics. And why this is so important is that as you make this transition, I talk to a number of very large companies every day, and these are some very risk-averse companies. They're not typically used to giving outside organizations access to their data. But if you look at the numbers, the growth in infrastructure spend in terms of server and server hardware and private data center spend was flat last year. Whereas spending in AWS, which is the largest single cloud provider, grew by almost 70% last year. So this spending is changing. This is a shift that's happening across the industry. And if you think about it, it makes sense. If you're a company starting today, why would you ever buy your own servers? Why would you ever buy any space in a data center? The cloud gives you a number of advantages. A number of them are technical. You don't have to run the hardware. Someone else does it for you. You don't have to pay for everything up front. You actually make this transition where the solution itself is sold month by month. As your business grows, your cost goes. It goes from a capital expenditure to an operational expenditure. So it makes a lot of sense why people are adopting this. And even very, very large companies I talk to are making a transition where individual projects will be spun up in the cloud simply for faster time to market. They can get their engineers access to the infrastructure they need to run the code they want to run as quickly as possible without having to get new servers stood up or new racks available. And they also do bursting to the cloud. If their business grows to the point where the private infrastructure they've already bought isn't capable of handling the load, basically their success has outrun their planning, a lot of large organizations will do bursting to the cloud. These are logical first steps as you make this transition. And this is where the spending in IT is actually going. Every number is pointing this direction, and it simply makes sense. But there's a number of things you really need to consider as your organization starts to make this change. First off, you need to really understand there are a number of different cloud solutions out there. Which one is right for you? Is it public cloud or private cloud or hybrid cloud? Is it software as a service, or is it platform as a service, infrastructure as a service? There's different caveats to all of these. We're not really going to talk about this today. There's a number of vendors out on the floor that do this and actually help you make this transition. Obviously, if you're going to be running your business on top of the cloud, you need to understand the pricing model to make sure that the cloud seems extremely inexpensive when you start. You want to run a server in AWS, it's 8 cents an hour. Okay, that seems incredibly cheap. Why would I ever not do that? Well, that starts to add up. It's about $175 a month. You start to have a lot of servers running up there. Those costs really can add up. So you do need to understand at scale what is the cloud actually going to cost. And right now, about 35% of the websites on the internet are run out of AWS. So, the team at AWS, they're about 5 times bigger than the next largest cloud provider. So I'm going to use them as an example most of the time. But this does apply to Google and Rackspace and Microsoft Azure. They do a really good job with security and availability. But you need to make sure that your application is secure, because if there's a breach, you're the one on the hook. You're the one who needs to make sure that your customers' data is protected. They will do their best to make sure that the servers they are running are specifically protected, but they're not actually going to encrypt your data for you, for example. You need to make sure you're making that decision on your own. And there's about 30 different offerings from AWS today. They're taking different components of solutions that you used to have to run yourself. You used to run a MySQL database on a Linux host. Now you can use DynamoDB. You can use a number of different business platform as a service offerings, which will take the load off of your team having to even monitor an auto-scaling group and make sure it's scaling. Just use services that they make available. So when you choose to make this transition to the cloud, you need to make sure your business, you make the right business decisions and you make the right technical decisions. We're not really going to be going into that. What we are going to be going into is how you make sure your users are happy with the experience they get. This is something that isn't really addressed from all the different monitoring providers today. Traditional IT monitoring tools were never designed for this type of environment. You simply can't measure performance over the open internet with something that's going to be collecting device-centric information. You get SNMP, you get IPSLA, you get WMI. These are all solutions that are designed to collect data from a device that you own to make sure it's functional. It's up, it's running, your software is running, the process is running. It tells you nothing once you leave your firewall. Even if you have something like IPSLA, which is designed to measure some performance metrics between Cisco routers that you own, you need to own both ends of the connection. Well, you don't own the other end of the connection in AWS or Google Compute Engine or Microsoft Azure. You don't own the other end of the connection to Salesforce.com. How do you make sure that the performance is good between your users and where these applications are actually being run? That's the challenge we're here to solve today. So in doing this, there are 3 different aspects of performance you really need to understand. First off, the end user experience components. This is where traditional IT management tools are still relevant. They are still meaningful because you need to make sure that your devices are up and running. If your local area network or your wireless network is not functioning well, it's going to be degrading the entire end-to-end circuit. So a lot of the traditional SNMP vendors, they're still going to be relevant here. They're still going to be meaningful. But what they don't really do is tell you the performance over these devices. It's really telling you, is the device up and running? Is the hardware functional? Is it out of memory? Is it pegging the CPU? It's not really telling you, are these devices actually working well together? Sort of the black sheep in corporate IT performance is wireless monitoring. We see this all the time where even like the largest, most well-funded companies in the world, their wireless performance suffers greatly. They're not getting anywhere close to what the theoretical maximum of their wireless networks are possible, simply because people don't really understand just monitoring the device isn't enough. And they're trying to take applications that were never designed for wireless and put them over wireless. Wi-Fi is simplex, which means it can send data or receive data at a single time. If you try to take something like a video conference or a voice over IP session and put it on a laptop like Microsoft Link and run it over your Wi-Fi connection, you can't talk and listen at the same time over Wi-Fi. It just doesn't work that way. So they're trying to take out these applications which were designed for wired networks and designed for environments which are completely under your control and put them on the latest technologies to make it available and accessible to people. What's going to happen when you try to do that? Your user experience is going to suffer. So you do need to measure performance from the end user, but try to measure it over the entire application delivery path. So what this means for cloud-based solutions is that when you do a conversion to public cloud, to software as a service vendor, you're introducing the internet between your users and the application. There's very few solutions that can actually measure the performance over the open internet. You can get something like BGP, which is designed to tell you basically what the how the route is determined between source and destination, but that's not really telling you your user's experience. And that's fundamentally what AppNeta as a company was designed to specifically solve. Measure over the actual application path from your users to where your application is hosted. What is the performance over the circuit, over a multitude of vendors, really over anything, over any type of network to anything that will respond to a ping or a trace route? What is the actual performance there? And this is challenging. This is something that a lot of people don't really think is possible, and it's really what we specialize in. And lastly is measuring into the cloud provider. So when you think of measurement into something like Salesforce, it seems relatively simple. There's a web server front end. They run 33 different data centers, so you're going to need to identify which one you're actually going to, but measurement to that actual endpoint is relatively straightforward. Where this really gets interesting is when you try to measure into this, the cloud providers. If you're to look inside of AWS, look inside of Google Compute Engine, look inside of Microsoft Azure, they're running really complex software-defined networks. You think that, okay, I hit some firewall, I might hit an IDS IPS system inspecting my traffic, I hit a router, I hit a switch, I hit my server. That's typically not the case. We have some videos later of actual performance inside of these cloud providers, and these networks are extremely complex and they're changing constantly. So the ability to actually see to the TCP stack of the virtual server you're running in the public cloud or in a SaaS provider is really required, because just measurement to that endpoint isn't enough. Is that going? Okay. So once your company has decided you're going to make a transition to a public cloud provider jump in with both feet or on a project-by-project basis or even bursting to the cloud, the first decision is which cloud provider to actually use. It seems really simple. People think the cloud is everywhere. It's this ephemeral thing that's spread over everywhere in the world. Well, that's not the case either. Google Compute Engine has 4 data centers where they actually run your code. AWS has 13. Microsoft Azure has 19. They are expanding. Google hasn't announced how many they're adding in the next year. AWS is adding 4 locations. Microsoft Azure is adding 5 locations in the next year. So why this is really important is when you take an application that was running locally, with sub-millisecond round-trip time from your users in your office to, the servers in that same building or your local data center, and you take that application and you move it to the cloud, you're introducing latency. It's just physics. The bytes will only go so fast between source and destination. And if you choose the wrong cloud provider in the wrong region, you're going to introduce latency that you simply can't remove any other way. So say you have offices in California, and you choose the default location for AWS is US East 1, which is in Northern Virginia. You just introduced 40 milliseconds of latency between your users and every call they make to that application. That's how long it takes a single byte to get from California to New York or to Virginia at optimal speeds. It's 20 milliseconds if there were no routers in between. The actual routers you're going to hit in the middle are going to introduce about 20 milliseconds of additional latency. So if you've got users in Japan and you choose US East 1, you just introduced 80 milliseconds of latency. So something that you're expecting to run with sub-millisecond latency, like last week before you made this change, things were responding very quickly. That database call you were making was responding extremely quickly. You make the switch to AWS for your users in Japan, it just got 160 times slower than it was last week. Same code, the databases may actually be running faster, just the physical distance of the network is really, really important. And you need to make sure you understand really what the options are from your provider. In addition to all those other elements we talked about for security and what services they offer, you need to make sure you're choosing the right geographic location, because they want you to think that the cloud is everywhere. It's not. And a key element about this is they will talk about thousands of locations for their CDN networks. If you look at CloudFront from AWS, they talk about thousands and thousands of locations. That's not where your code is actually going to run. If you actually go get an AMI from AWS, you have to choose one of their 13 locations. They can't actually run any code at a CloudFront point. So you have to make sure you know exactly where that's actually going to be. So first takeaway, let's minimize that geographic distance. This is something that should be very straightforward. This is, if you're choosing physical data centers, this is something you've been doing since day one. This requirement does not go away when you make the transition to going to the cloud. It is still relevant. Once you choose your providers, you need to monitor continuously. So what we've got here is real data from our 10 gig data center in Boston on the left is Google Compute Engine, on the right is Microsoft Azure. And these providers do a really good job. So this is leaving a 10 gig data center. We're getting somewhere between 1.5 and 2 gigabits a second into each of these cloud providers. So generally, they're doing a good job. Everything is working relatively well. But what you see on the right with Microsoft Azure is we're seeing about 16% packet loss on the return from Azure back to our office. So just because the data center is up, you're getting IP tone, it's available, that doesn't actually mean that it's working and that it's working well. This is really something that you need to make sure you're measuring this performance all the time. Because once you go to a cloud provider, it's wonderful that someone else is going to run it for you, but they're doing that same thing for thousands of other customers. And you're sharing that infrastructure with, in the case of AWS, you're sharing it with 35% of the internet. And they actually have a syndrome they've identified called the bad apple syndrome, or the noisy neighbor syndrome is another version of it, where you spin up a virtual machine inside of AWS, you're on the same physical hardware as some extremely popular website, their performance is actually going to pull resources away from you. And you think, okay, this is something that they should be taking care of. You can mitigate it to some degree by getting what they call a VPC, or a virtual private cloud, where you are getting your own rack of hardware. You're the only consumer on that hardware, but all the network infrastructure is shared as well. So yes, you get that virtual machine, you get the physical hardware that the virtual machine is running on, but you're all sharing the same switches and routers connecting it to the internet. So you do need to measure and measure continuously once you choose a cloud provider, because this does change all the time. We see huge swings in the performance actually delivered by cloud providers. Actually, I think I have a slide on this, where this is up to about last week. We measured just for a month from that 10 gig data center into the 3 major cloud providers: Google Compute Engine, Microsoft Azure, and Amazon Web Services. And we measured bidirectionally, because the internet by nature is not symmetric. When you send bytes from source to destination, there's no guarantee they're going to come back over that same route when it returns. Actually, when you look at the data, about 98% of the time, it actually takes a different route from the destination back to the source on the return. So we're going to measure each direction independently. And there's huge swings in the performance we actually measured. So AWS, they have the lowest overall performance at averaging about 345 megabits a second upload and 671 megabits a second download. But they bottomed out at 2.3 megabits a second. So this is a great example of how you need to measure performance continuously, because it's going to be changing. That infrastructure we were on was shared with some other customer that was consuming huge amounts of bandwidth, and it simply wasn't available to our virtual machines. They had a peak of 774 megabits a second. That's wonderful. Your app will run fast, but it's that 2.3 megabits a second that's going to kill you. And similarly to Microsoft Azure, they do have good overall performance in terms of the bandwidth available, but the quality of the bandwidth is not as steady. That 16% packet loss is really critical. And for those who aren't super well versed in this, if you have 2% packet loss, your web application performance will be cut in half. So if a page used to take 2 seconds, you have 2% packet loss, it's now going to take 4 seconds. If you have 5% packet loss, your web application will functionally be unavailable to the user. It will slow down by about 8 times, about 800% slower. 16% packet loss, your web application just simply isn't going to work. Users will get frustrated, they will leave. This is the case where you're using this to Salesforce.com. People can't just, your employees aren't just going to go to another CRM system. What they're going to do is open another browser and just start cruising around on the internet. Their productivity will drop. So you need to measure that number, even if it's outside of your environment, so that you can hold those providers responsible for this poor performance. And even the best overall performing network within a cloud provider we've seen is Google Compute Engine. Again, it's a trade-off. They've only got those 4 data centers to choose from, but their performance has been really, really good, really, really solid. But in this case, we actually saw something quite interesting. And this is really the crux of this entire talk is these cloud providers do a really good job. These environments are built from day one to be resilient, and that they don't go down. You won't see like major outages. It's very infrequent for these providers to have huge portions of the infrastructure actually be unavailable. But what we're actually seeing here is Google Compute Engine was giving us about 2 gigabits a second in each direction, but then we saw a network failover. Google's their own major internet provider. Obviously, they have dark fiber going everywhere. But that 2 gigabits a second was cut in half down to about 1 gigabit a second when they failed over to their backup provider, data pipe. And down below that, you actually see the latency from Boston to that Google Compute Engine data center was about 10 milliseconds. As soon as that failover occurred, it quadrupled. It went up to 40 milliseconds of latency. So my app was not actually down, but my performance was greatly impacted by this. The available capacity cut in half, but every transaction took 4 times longer than it did before. And web applications are really, really chatty. On average, you want to start up a session. It'll be about 8 round trips to start up do the initial handshake, start up that web request. And the average web page consists of about 80 different elements today. So you're going back and forth 80 times to get all the objects to render that page. And that round trip just got 4 times slower when that failover occurred. So my app isn't down. It's just slow. It just slowed down by 4x from where it was before. But all my monitoring systems would say, yep, the app is up, we can reach it, it's just fine. So performance is not availability. And that's why the talk is really called slow is the new down. These vendors do a really good job. These data centers don't go down, they're designed to be resilient. The memory in the hardware itself is designed to fail over automatically. What they don't guarantee you is performance. And you need to measure that yourself to really make sure that it's working, because huge portions of this are outside of the cloud provider's control. They don't control your wireless network. They don't control your local area network. They don't control your ISP connection from your vendor. If you want to make sure the performance round trip across your environment, your ISP's environment, the open internet, and into the cloud provider is actually working and working well, you need to really take the lead here and monitor performance from start to finish. You're the only one with that visibility to do that end-to-end performance monitoring from all of your locations. We do highly recommend monitoring over Wi-Fi, because that is really the black sheep of IT performance. You need to make sure that that's working and working well. You need to monitor your ISP, make sure they're giving you what you pay for. You need to measure over the internet as much as possible and into that cloud provider's environment. And this isn't a one-time job where you just do this initial assessment. Everything's working wonderfully to Google Compute Engine or AWS or Azure or whoever you choose on day one. That's going to change. On some of those videos we saw, there were these little yellow diamonds on those charts. That's actually a route change. The route taken from source to destination changes into these providers on average every 5 minutes. So the performance you saw 5 minutes ago isn't really relevant to what's happening right now, because the route you're taking from source to destination has changed. That's just the nature of the internet. It's going to be changing constantly, so you need to be measuring constantly to make sure it's working and working well. Now, once you're in the cloud environment, you need to make sure the networks inside of the cloud provider is actually working and working well. The driver behind this is a change we've observed within our customers, and it's really the adoption of what are called microservices. People are taking large monolithic applications that they built, and they're breaking them up into small services that do one job and do it really, really well. And what this lets you do is optimize the performance of any given function and really scale any given function based on the load required to deliver the overall performance. A good example of this, we have a customer who's a large marketing service SaaS provider. You may think of them as one website. I go to this website, my marketing team uses it to do our ad buys and do our optimization and our monitoring. You think of it as one monolithic system. It's actually 175 microservices. And you need to monitor, if you make this change, your developers are making this change, you need to make sure that you're measuring the performance between all the infrastructure now running your code. And this isn't just cool startups that are starting from scratch today, making the leap into microservices. This is from February in Wall Street Journal. Goldman Sachs is shifting 90% of their computing infrastructure to microservices. They are making the change with all of the apps that they run internally to go to microservices because it's a much more efficient way to develop code and make sure that it's working and working well. So this is, if you've ever heard the term or the company Docker, they're leading the charge here. They're making it really easy for people to take their code, break it up into these individual containers, and then scale the number of containers doing any given job based on the load within the system. And this is the best way to make a performant application. But what this actually means is that the apps themselves are becoming more distributed within the clouds and actually between the clouds. AppNeta isn't a huge company. We have about 160 employees. We actually run our solution across 2 different clouds because our developers are choosing the right technology to do the job at hand. We have most of our code running inside of AWS. We have some other components running inside of Google Compute Engine because Google offered a service that we didn't need to build ourselves. We just sort of used their capability. It was the right tool for that job. So we have the internet between AWS and Google, and we need to monitor it constantly. And this type of change is really prevalent in the customers we're working with, and we see it really going wider in the industry every single day. But when you think, okay, I've just broken up my monolithic application, it's running inside of AWS, okay, these virtual machines are right next to each other, right? I should get a gigabit connection between them. That's what I get when I buy an AMI from AWS. Isn't that the case? It's not the case. You guys need to really read the fine print when you sign up for AWS or really any cloud provider. The most common AMI image sold by AWS is called a C3 extra large. That's the equivalent of a powerful modern server. If you just buy that default solution, they guarantee you get one virtual gigabit connection, but you're only guaranteed 62.5 megabits a second actually available to that image. There's tens of thousands of other people using AWS at the same time. So that gigabit connection is not going to get anywhere near gigabit speeds unless you explicitly pay for it. They do let you buy high-performance networking to get higher than that speed. You can go up to gigabit or multi-gigabit solutions. You have to pay extra for it, though. You have to know enough to do that, and you have to pay the premium to get high performance within the cloud providers themselves. So this is actual data from one of the AppNeta services. So we're running in this case, it's actually all within AWS. We have a sharded database system, which, for performance reasons and security reasons, we break data up hour by hour and customer by customer to make sure we isolate individual databases for performance reasons. So one system running Python is actually talking to 128 different Postgres databases running within the cloud. And inside of AWS, there's actually 8 layer 3 hops between that virtual server and that virtual database. Performance is good. We're getting more than 2 gigabits a second that we're paying for, but we're seeing upwards of 9% packet loss within inside of AWS. This is what you think of the LAN running in the cloud. This should be no packet loss. If your IT people were doing this on your local network in your data center and they had anything higher than 1% packet loss, they'd be fired immediately. You just don't have the visibility inside of AWS to know that this is actually happening. And this is why a lot of the vendors, like even within CloudWatch from AWS, they will actually do what they call the bad apple check. When you start up a virtual machine, they'll make sure that it's performant. They guarantee you the CPU, they guarantee you the memory, but they don't actually guarantee you network performance or storage performance. So they actually do checks and what type of storage performance am I getting, what type of network performance am I getting, and if that data really isn't good enough, they'll shut down that image and start up another one. That's really how they deal with this. If you get a bad one, just throw it away and get me another one, because they don't have a way to actually fix this problem just because they're growing so fast and they're taking on so many new customers every day. There's no ideal way to solve this solution, solve this problem. So even within these cloud providers, the networks themselves are extremely congested and extremely complex. You need to measure all the way to your servers to really figure out what's actually happening. So just to summarize, minimize the geographic distance between your users and the data centers. You need to measure constantly. This performance is changing all the time. Every minute, every day, you need to make sure this is working and working well. When something goes wrong, it's not typically going to be caught by something that's just measuring uptime and availability, because these are resilient environments. It's not going to be down. It's just going to be slow. So you need to measure performance and not availability to do this properly. The applications themselves are becoming more distributed. They're going to microservices. You need to make sure that those distributed applications are working well within a cloud provider or across cloud providers. And you need to choose the right solution that can give you the visibility all the way from your end users over that entire application delivery infrastructure to where the apps are actually running. So are there downsides of doing this continuous monitoring? We say no. If you do it properly, you choose the right tools. We're designing this to be extremely low overhead from day one, less than 1% overhead on both the servers they're running on and the networks they're running on. If you do this properly, you can make sure that there are no degradations in performance. We're not going to consume capacity to measure capacity. That's really the hardest part of this problem. How do we actually measure performance without impacting the users themselves? This is really the crux of what we're doing. But we believe we've cracked this problem. We're happy to show you how. So I know we're just at time here. Any questions? And we have all this running live at booth 213 if you guys want to see how this would actually apply to your environment, any applications you're actually running.
Thanks. If you have the floor is open. If you have questions, please come up and talk to us.